First time it's ever actually worked. Maybe. Okay. As mentioned, I'm Gary Bernhardt. On the computer, I look like this. I own a company called Destroy All Software that produces screencasts on various development topics. And one of the nice things about producing screencasts is that it takes me maybe 10 hours per week to produce one. And the rest of the time I spend idly thinking or playing with side projects just to keep myself interested and to find new things to talk about. And this entire talk is the story of one of those side projects which I've been working on for a little over a year in secret. And the title of the talk is A Whole New World. I'm going to make 3 confessions in this talk. The first of which is that I have written an editor, a text editor. Its name is an editor, so if I'm at a terminal and I fire up an editor on a source file, this is, yes, it is going, right. So if I whack enter, fire up the editor, this is editing part of a Twitter client, another project I wrote for fun. But it looks a lot like Vim or Emacs or any terminal editor. It is not like them. It does a lot of things that they don't do. Now it is a modal editor. I like Vim, as anyone who has seen my screencasts knows. So I can do things like visual line-wise select. It's keystroke compatible with Vim in terms of basic editing. So yes, it's modal. Yes, it is actually terminal only for reasons that will become clear later. It is not Vim. It is much more powerful than Vim, but it is not an IDE either. It's not some giant ball of millions of lines of code or however much is in something like Visual Studio. There's no debugger in this editor. There are other very powerful features that are not in other editors, like it has this idea of layers. I've been wanting this in my tools for years. The idea of overlaying sort of orthogonal information onto the source code. For example, the sort of classic example of this is a diff layer or a diff mode in something like Emacs. If I'm looking at some source code, I whack a single key, it inlines the diff. Sort of uninteresting, most editors can do this. But here's a much more interesting layer, the crash layer. So your system is running in production, it's emitting tons of log files that look like this maybe. I'm using Ruby for all my examples. Sometimes the logs contain crashes, they contain uncaught exceptions with tracebacks in them. So if you load these production logs into an editor, it can, as you're editing the code, and when you whack a single keystroke, it can overlay the traceback onto the source code. So every line, all 1 lines that are yellow here, were involved in a crash. And I can narrow onto a single traceback and move up and down it. So if I move down this traceback, the red line is where the crash originated. So as you're editing the source code, you hit a key, there's 0 delay, and it shows you everything on the screen that has ever caused or been involved with a crash, which I think is very useful information that we don't currently have. Right now, your exceptions are maybe stored in some web-based system. You have to open a browser, log in. It's very cumbersome as a process. So I've tried to integrate it into the editing experience. Now, as I go through, the first 2/3 or so of this talk is just explaining this thing to you. I'm going to show you features, and then I'm going to show you how it works, how the editor does this. So this one's pretty easy. For diff layer, it just does a git diff, not difficult. For crash layer, it's a little harder. It has to parse the logs, of course. It has to know how to find the tracebacks and read them. But it also, the problem is that the production box might be running a different version of the code. So if the production box ever printed into the log what version it was running, what git hash it was running, then the editor will actually fast forward that through time to the current working copy to figure out what lines are what, so it can display them properly. Or occasionally it gives up because it's ambiguous, it doesn't know. So layers, those are some basic layers it has. It also has more powerful ones. But that's sort of, I wanted to start with that because it's a simple feature. Here is a much deeper and more complex feature. The editor knows about all the interactions between all the units of code in your system. And by this I mean classes in Ruby. In a language like Clojure, this might be namespaces and types and things like that. If I'm looking at some source code and I whack a single keystroke, it pops up a graph of the interactions between the classes. And this is starting at the test for the current file I was looking at. Now, I told you this is terminal only, so this should immediately make you ask a lot of questions about what the hell is going on the screen. Allow me to cause you to have more questions. I can actually scroll through this graph. It's interactive. So you just saw me scroll from the database spec at the top down into the tweet. If I whack enter on that, I'm navigating the system dynamically. Tweet has no outgoing interaction, so it's a value object at the sort of root of the graph, or excuse me, at the leaves of the graph. If I switch it to incoming edges, then you can see all the things that reference tweets. So I'm just sort of like dynamically navigating through the system, observing how the objects interact. So how does it do that, especially in a terminal? Well, in terms of the data, we need to retrieve and store the graph information. You might have seen that and assumed that it was doing static analysis. There is no static analysis in this editor. I think static analysis is not the wrong thing for dynamic languages, but I've never seen an implementation that convinced me that it was really useful. Instead, it's auditing all the test runs to learn how the objects interact. So whenever it runs tests, or actually whenever it forks any process, it has an environment variable called Ruby_audit if it's in Ruby mode. In other languages, the variable changes names. This points to a FIFO, a named pipe on the disk. In your tests, you're going to say raudit.auditbang, which is going to enable the entire auditor. That's going to fire up the profiler, turn it on. It's going to turn on a trace function, so it observes every line as it executes. It's going to set an @exit handler for the process, so that when the process exits, all the profile data and all the tracing data get dumped out to that FIFO that was named by that environment variable. And so it's going to dump out a profile database, a trace database, and it's going to dump out an unstyled dot file, a graphviz dot file. That's the format that I use for the object graph. So that's just retrieving the data. To query it, for the simple case, like the one I showed you, all we have to do is take that dot file, throw some styles in, and push it into graphviz, so that's easy. The rendering itself, fortunately, graphviz takes dot data on standard in, emits images on standard out, so I just fork off the graphviz, throw data into it, read data out, and everything's good. It needs to be fast, so when I initially bring that up, it takes 200 to 400 milliseconds. Then I fork off a pre-rendering process that will pre-render all the movements I could make through the graph. So if I do make those movements, then they're already there, sort of like prefetching in a web browser. So that's how it works. And there are a lot of useful questions you can answer with something like this. Like, I'm writing a web app. A request comes in and hits this piece of the controller layer. What code gets executed? That's a question that is not that easy to answer with most current tools. Just seeing the graph of what actually happens. Or what code does this test run? That's actually even less common to be able to do. Or maybe the best one, the most interesting one, what code might hit this crash point? So we already have the production logs. We know where crashes originated. We can back out a graph of all the code that might have come into there from other places. And we can even organize it maybe with the left-hand side being code that did cause a crash, the right-hand side being code that didn't, all the paths coming into that one line, and why did some of them cause a crash and some didn't? We can ask questions like that. None of these are implemented, but the data's all there. But of course, the big question is, how in the hell did I just draw raster graphics in a terminal? Well, you will remember that there were 3 confessions I was going to make, and I've only made one of them. So I've written an editor. I've also written an terminal. So let's digress for a moment and I'm going to just rant about terminals for just a minute. This is my configuration for iTerm2. It's a terminal I use in all my screencasts, and the one I used before I wrote one. It's currently configured for Xterm. Xterm is basically doing VT100. VT100 is also ECMA 48, ISO 6429, ANSI X364, or just ANSI escape codes. These all mean the same thing, pretty much. And it all goes back to this piece of hardware, Digital Equipment Corporation, VT100 terminal, 1978. This is where the terminal protocol we're still using comes from. To digress even further, here's a graph you've all seen before of transistor counts and CPUs. At the right, you'll see, I don't think you can read the words very well, but you'll see an Ivy Bridge CPU that's a current Intel CPU. 1.4 billion with a B as in boy. 1.4 billion transistors in that thing. A P4 is the 4th one from the right. You can see it basically has 0 compared to an Ivy Bridge. So if we scope this just to the P4 has, what is that, 40-something million transistors. And you can see that a 486 basically has 0. So let's remove Pentium, scope it to 486, and you can see at the left there, the 8008 and the 8080 basically have 0 transistors. They both have on the order of 10,000, I think. The 8080 CPU, the one with 0 transistors compared to a 486, is this, and this is the CPU in a VT100. You can see it's in a dipped package. I'm pretty sure I could hand solder this even if I were drunk, and it would be fine. This is the CPU that powered the machine, that defines the terminal protocol that you all use every single day. And I find this, I don't necessarily think old things are bad. I love Unix, and Unix is old. But this I find pretty offensive. And so the things I wanted, the reason I wrote this terminal is I wanted raster graphics on the grid. So it's still a terminal, it's still a character grid, but sometimes a character is a blob of raster data. So it's still easy to think about writing software for this. You don't have to think about arbitrary pixel positioning and views and stuff, but you can throw raster graphics in for simple things like the interaction graph. 24-bit color. If you've ever tried to get 256 working, you'd know that stepping into the 90s is very difficult in 2012. So I wanted to try to fix that. Italics and bold and underline, basic text stuff that the original Macintosh had in the 80s. Momentary key presses, like I whack control and then release it. I want to be able to see that in my editor. I didn't show this feature, but it actually has a feature where if you hit a keystroke, it shows you, it opens a split for the definition of a function under your cursor, and then you let go of the key and the definition goes away. So it's a very quick way to just see sort of offhand data. And finally, I don't like mice at all, but some people do, so it does support the mouse. So that is why I wrote a terminal, and now let's go back to the editor and see some of the more powerful layers. I showed you the simple diff layer, the slightly more complex crash layer. There's a performance layer, which is really cool. So you're looking at some source code, you whack a single key, it overlays on the left performance information. Most of those lines have a gray marker on the left. That means that it was in the bottom 95% of the profile. Yellow means top 5%. Red, which is the very last line of the source code, means top 1%. So single keystroke, no wait time, you can see profiling information. It also has a series of type layers, maybe the most interesting for a conference like this. Remember, this is Ruby, but with a single keystroke, I can overlay type annotations onto every single function. These are not, it is not doing type inference here. Remember, there's no static analysis. This is by observing the system. And I can also shorten identifiers, so this is the shorten layer. At this point, as soon as I turn this on, the code becomes read-only within a line. But now it looks quite a lot more like maybe Haskell would look or something, where you can glance at the type information, that tells you what the function is doing. You can see the structure of it because the names are short. And finally, a third type layer. It can annotate every line with the type of the expression on that line. Just sometimes sort of useful to see that. And then when I turn all these off, code goes back to normal. The code never changed, only the representation on the screen changed. So how does it do all that stuff? Well, actually this one's not that hard to explain. The performance layer just loads all those profiles that were dumped out by the auditor during test runs. But of course you don't want to see profiling data for unit tests, that doesn't make any sense. So if you tell the editor that my perf tests live in this directory, it will only use those for the perf tests. And in fact, you can write a single perf test that for the thing you're curious about, scope the layer to that, turn the layer on, run the test, and with a couple of seconds of time, you can see the performance data that for the test you just wrote in line with your source code. The type layer is also pretty easy to implement. You just load up that trace data that the auditor dumped, and it sounds expensive, but it's not. Type inference is expensive because there's a graph it has to crawl, but if you've just recorded every single call point in the whole test run, or in every test run, it's a linear scan of that to find out what the types of a function are. Finally, you can turn all these on at the same time if you want. It makes it kind of hard to read, but the most magical part of this is that if I go into visual line mode and select those bottom 3 lines, that bottom function, and delete it, it marks it as deleted, but it's still being rendered. So all of these things can work together, and you can still edit the code. You can't edit within a line with shorten layer on, but with all the other layers, you can actually even edit within a line. So assuming, so this system has all this knowledge about the structure of your system, the crashes that have happened in production. Would you be, if I release this editor today publicly, and it supported your favorite dynamic language, would you use this? Do you think you would use this? Do you think you might use this? Okay, a lot of hands. I'm very glad to hear that. I'm also a little disappointed because I haven't made my third confession yet. I wrote an editor I wrote in terminal. I also told you and lies. I did not actually write an editor. I did not write a terminal. Everything you just saw was actually all Keynote. That was all text boxes in Keynote. Yeah, it's a lot of hours of my life you just watched go by. It takes a long time to fake that. Now, the reason I just did this is that I tried to design a talk demonstrating something where if I were sitting in the audience and saw it, I would be, number one, excited that this existed. This is what I want to exist. But number two, I would actually be surprised that someone had built it. Now the editor I would find fairly surprising, but the terminal I would really find surprising because the terminal is infrastructure that we don't really replace ever. And now I want to quickly ask the question with my small amount of remaining time, why would that be surprising to me, and why was it maybe surprising to you to see that someone had not only written an editor but rewritten the entire terminal layer? I think there are two big reasons that this would be surprising. And the first is that we have this shipping culture that is poisonous to infrastructure replacement. You have people like Seth Godin saying things like ship often, ship lousy stuff, but ship constantly, which I think is a great way to achieve short-term business gains and a great way to discover what your customer wants. But when you're a programmer and you are the customer and you're writing the system and you've been using these tools for 20 years, you don't need customer discovery. You need to go off and sit in a hammock for a couple of years and think hard, which I know has come up at this conference before. The second reason I think this is sort of surprising is that we have not only all this legacy, like VT100 or AutoConf. I don't like saying that word, but we have not only the legacy, but we have a paralysis around it. We can't even imagine replacing it. I mean, VT100, 1978. A lot of the people in this room weren't alive. I wasn't alive in 1978. And probably very few of the people in this room were actively programming in 1978. So these things have existed forever for us, right? We can't see the ways in which they're bad a lot of times, or we just don't think about it. So the way that thinking about this editor started was I had all these ideas for an editor. I had them in my personal wiki, sort of in a wiki page, and I realized pretty early on that you would have to write a terminal to build this editor, or it would not be in the terminal, which is unacceptable to me, because Control-Z is a thing that I want. So I realized I would have to write a terminal, and I thought about, what does that really entail? Well, terminals are coupled to the kernel via ioctls. There's a lot of ioctls that terminals have to use, on both sides of the terminal, ioctls happen. There's the TTY and PTY subsystems. Those are part of the kernel. So now I'm basically thinking about making kernel changes to support my terminal, which seems very difficult in today's world, right? You can't submit a patch to the Linux kernel. Well, we're changing the nature of terminal, guys. Here you go, here's the patch. It will not be merged. So I'm not exactly sure what the answer to this is, but I think that it is basically embrace and extend. I think you build a new terminal protocol, you make it backwards compatible, and you just throw PTYs and TTYs away. But no one does things like that, right? No one papers over, really replaces the low-level infrastructure. The second thing that this is something I've observed from other people, is that talking about this actually makes some people mad, like mad. They're actually angry that I will talk about what a new editor might look like, or what a new terminal might look like, or what a new Unix might look like, which doesn't make sense to me. And some other people just think it's stupid. They think it's masturbatory to talk about this kind of stuff. That part I understand, at least, but I don't agree with. So if you're in this camp of why would we worry about the low-level infrastructure, why would we do full redesign of low-level things that have existed for 40 years, I'd like to present this hypothetical timeline of a piece of infrastructure being developed, where in spring of 2005, someone decides to work full-time on this thing, to redesign a piece of infrastructure we've had for a very long time. For the first year, they just think and prototype until spring of 2006. And then in spring of 2006, they start implementing, and in fall of 2007, they release this thing that they've designed for 2.5 years. Without it being public, they release it into the world. Does anyone know? I assume someone must know what this timeline is. Oh, good guess, Git. I hadn't even thought of that. No, this is actually Clojure. This is the timeline. I emailed Rich to make sure I had my dates right. This is the timeline of Clojure development. 2.5 years before it was public, and a full year of that was just thinking and prototyping. And I think this is kind of what you have to do to redesign infrastructure, right? Rich didn't just like pile some crap on top of Lisp. He took the entire Lisp and moved the whole design at once. And that's something you can't, at least I don't think you can get by incrementally, doing incremental development. I think you really have to step back and think hard and spend a lot of time laying in a hammock, staring at the sky. So, I realized this was a really weird talk. When Alex invited me to do a lunch talk, I decided to do something totally crazy, and usually my talks are not giant lies. So, I am Gary Bernhardt. I own Destroy All Software, which produces screencasts, and I thank you guys very much for letting me lie to you for 30 minutes.